So let's do an example. We have an 8 kilogram object moving 4 meters per second. Let's call this one ma. Call this one initial velocity of object A, positive x direction. And then I have a 2 kilogram object. Let me call it MB, moving 3 meters per second in the negative x direction. So let's call it VB1, initial velocity of object B. Now after the condition, the final velocity of MA is 2 meters per second in the positive x direction. So it's VA2. We want to find out what's the total kinetic energy of the system after the condition. So let's first sketch the situation. Sketch the situation. We have, before the condition, 8 kilogram moving 4 meters per second, and we call this one MA, VA1. And then you have 2 kilogram moving 3 meters per second, VB1. This is MB. This is before the condition. And then after the condition, what do we have? We have 8 kilogram moving 2 meters per second. Now we call it VA2, final velocity of object A. And well, the question didn't give us what's the velocity of object B after the condition. It asks us what is kinetic energy after the condition. K2, it should be calculated as 1/2 MA VA2 squared, kinetic energy of object A after the condition, and then 1/2 MB VB2 squared. This is KA2 KB2. It seems I already know what is MA, 8 kilogram, VA2, 2 meters per second. I know what is MB, 2 kilogram. I don't know this. So it's really about how to find the VB2. And it's a condition, right? It's a condition. So apparently momentum should be conserved. I should have P1 equals P2. Can we solve the final velocity of object 2 using momentum conservation equation? So yeah, let's try. Let's try to write down the equation. Momentum conservation. So the condition tells us momentum is conserved. You have initial momentum equals final momentum. And the initial momentum and momentum of object A, momentum of object B before the condition equals momentum of object A. After the condition, momentum of object B after the condition. Now plug in all the numbers. 8 times 4 plus 3 times the mass is 2. 2 times, okay. Now this time we need to go back and double check what's the velocity of mb? So we have choose this to be our positive x. So actually, before the condition object, the b is moving in the negative x direction. So the initial velocity of VB1 actually is -3. MA is 8. After the condition is 2 meters per second, and B is 2. So we have one equation, one unknown variable. We can just solve it. This is 32 subtract 6, 16 plus 2 VB2, 26, 16, so 10. So we can solve the final velocity of VB is 5 meters per second. Now we can go back here and calculate what's the kinetic energy, right? 1/2 8 times 2 square plus 1/2 2 times 5 square. And this gives us 16 plus 25 joules, 41 joules. This is our answer. So the final kinetic energy of the system is 41 joules. Okay, final equals 41 joules. Okay, now let's do a complete inelastic condition problem. It's very similar. Same initial condition. Now it's just after the condition, we don't know what's the velocity of either of them. It asks what's the total kinetic energy of the system after the condition. But anyway, it's a condition, right? And condition means momentum is conserved. So, and after the condition, MA and MB should stack together. So let me draw after the condition. After this condition, you have 8 kilogram, 2 kilogram. They should have the same velocity. Let's call it VF. They move together. And so we have momentum conservation equation. MA VA1 plus MB VB1, that's the initial momentum. Final momentum MA VA2 plus MB VB2. But VA2 VB2 they all equals VF. I can replace. Let me keep it. MA VF plus MB VF. So it's MA plus MB VF. So already calculated, the left hand side is 8 times 4, subtract 2 times 3, give me 26, right? So to solve this one, this is 10 times VF equals 26. VF is 2.6 meters per second. That's the final velocity of A and B stick together and move together. Okay, now I need to find the final kinetic energy of the system as before. Kinetic energy of object A, that's just the KA2, KB2, 1/2 MA VA2, which is 2.6. 1/2 MB VB2 squared, which is 2.6 meters per second. So 1/2 MA plus MB VF squared, 1/2 times 8 plus 2 times 2.6 squared joules. Now we need to use a calculator to find out the answer. 1/2 times 10, 2.6 times 2.6. So roughly 29 joules. Okay, so hopefully we understand how to solve problem in condition now. I will see you next time.